See a simple image processing stuff in .NET. Okay, let's create a new solution. Our first role is to display an image. In the form. Okay, you can display an image in a picture box, a control called picture box. Let's rename the picture box to say pic image 1. Now how do you want to display the image? Let's say that user should be able to browse, select and display an image. Let's give a browse button. Okay, let's say button browse, and let's change its text to browse. So as user is browsing, I want a file open dialog to open. Fortunately in .NET we have a class called open file dialog. OFD is equal to new open file dialog. OFD.show dialog will show a file open dialog. Okay, now user may always select a file to open or cancel it. Accordingly, the dialog result will be either OK or cancel. If only dialog result is OK, I am going to process that file. The file name should be present in OFD.filename. .NET has a class called system.drawing.bitmap. Okay, we'll be working with that bitmap class extensively. So using system.drawing will include that. Oh, it's already included, system.drawing. Okay, now .NET has a class called bitmap. Bitmap BMP is equal to bitmap dot from file fname. .NET has got two images. One is called the image class system.drawing.image. One is the bitmap class. Image class doesn't permit you to have any operation on that image. Okay, you can just open and display the image. However, the bitmap class allows you to manipulate that image also. Bitmap.from file now bitmap.from file returns, as you can see, an image object. That image object can be easily typecasted to bitmap. Either in .NET you can typecast it in this fashion, or you can write both are supported. Okay, and then pic image1 dot image is equal to BMP. Let's run this. As we browse, a file open dialog gets opened. Let's take one image. This is the image is displayed. Again, let's browse, cancel it, nothing happens. Let's browse, take one more image. Now see what happens. You see, only part of the image is visible. Why? Image is too large. So many a times while displaying, we may want to display it to fit the size of the picture box. Okay, how you can do that? By creating a new bitmap, comma, you can specify the size. Size is nothing but pick image 1 dot width, comma, pick image 1 dot height. So at the time of displaying, you can create a new bitmap from the old bitmap by changing its height and width, and you can just put it into your picture box. Okay, this is going to be always formatted to fit into the size and width of your picture box. Right? Okay. Now, let's say that I want to make some operation into the image. So for that, I may want to include some other buttons also. So from the other button, I cannot access the variables which has been declared in this event handler, right? Let's then declare this bitmap outside, initialize it to null, and okay, such that BMP becomes a global variable. You can access it from any other directory. Every image is basically comprising of pixels. Okay, each pixel in turn is 3 bytes, which is a combination of red, green, and blue. If you open MS Paint, let's say draw anything. If you choose a color picker and say edit color, you'll see this color is comprising of some combination of red, green, and blue. By keep changing this red, green, and blue, you can change the color. Every time you make a change, the color is going to be changed. So every color is represented by some combination of red, green, and blue. Now, let's assume that I want to do some processing and put it in another picture box. As I said, creating another control is not a problem in .NET. Okay, let's change this name to pick image 2, and let's do a simple operation called many of the image operations are point operations, which means that you want to put that operation on every individual pixel. So I want to convert BMP image into a grayscale image and want to display it in picture box 2. If I click grayscale, I'm going to first check if BMP is not equal to null. Else, I'm going to prompt the user to select an image first. Right? Now, what I can do is, if BMP is not null, for int I equal to 0, I is less than BMP dot height I plus plus, because height represents number of rows. For int j is equal to 0, j is less than BMP dot width j plus plus. Let's create one more image. Bitmap BMP2 is equal to BMP dot clone as, so you can clone any object. Cloning means if you just write BMP2 is equal to BMP, both will be having same memory. So any change you make in BMP2 will also be automatically reflected in BMP. You know that object of a class are reference variables, which means that they act almost like a pointer. Now we can take a pixel value, we can take a color value using this. Color C is equal to BMP dot get pixel int x. X is nothing but fit into, go into column, x will be j, comma y is nothing but I. Okay, every color is comprising of red, green and blue components. So int red is equal to c dot r, okay, int green is equal to c dot green, and int blue is equal to c dot blue, right. There is a RGB to gray formula. Which is like this, okay. So let's say int gray equal to because all of them require double operation. Let us first double of R, double of G, and double of B, okay. Now color C1 is equal to new, color dot from ARGB. Here you can specify red, green and blue. For grayscale all of them should be same. So let's say gray, comma, gray, comma, gray. And let us put this color back into BMP1. So BMP1 dot, BMP2 dot set pixel int x j comma I comma new color is C1. At the end let's put picture box image2 dot image is equal to new bitmap BMP2 comma picture image2 dot width comma picture image2 dot height. Let's see how it works. Take this image for example. Let's try to perform it into grayscale. Okay. Let's take one more image. Let's take one more image. Let's convert it into grayscale. This is a big image, so it's going to take a bit of time, but we've got this image being converted into grayscale. Okay. Now I want a little different thing. What I want is, I want to calculate the motion vectors by comparing two video frames. Okay. Let's put one more browse button over here. So we now know using get pixel and set pixel, we can perform operations on the images. Let's again take a browse and let's also declare BMP2 globally. Okay, and let's copy paste all the codes that we had done over here. All the code we had done, let's paste it over here. Instead of BMP, let's take BMP2. Instead of picture box 1, let us take picture box 2. Okay, so now we can take one image here and we can take another image this is BMP2. So you can take two different images, one image here and let's say one image here. Let us assume that these two are part of two consecutive frames from a video and I want to calculate simple motion vectors from them. Okay. Let's say motion vectors. For that, let us create a simple video sequence. Let's say we have a person. Let's say this is sequence 1. Let's say this is sequence 1. Okay. Now, let's create one more video sequence which is little bit of different than this, where the hand is little down. Okay. Let's make it sequence 2 and let's open sequence 1 and let's make this change. Okay, such that if I run this program and as I browse, this is sequence 1. If I browse, this is sequence 2. I want to know where exactly the change has happened within the context of these two images. So, I'll take this loop. Okay, and I'm going to change this because I right now know what is the for loop structure. Here, if BMP is not equal to null and BMP2 is also not equal to null, both the images should be present. Color C1 is equal to BMP.getPixel, color C2 is equal to BMP2 dot get pixel, right? And R is not is equal to C1 dot R minus C2 dot R. Let's take it absolute. Math dot absolute. Similarly, C1 dot G minus C2 dot G. Let's make it absolute. Okay. C1 dot B minus C2 dot B. Let's make it also absolute. Okay. Let us now convert this value into grayscale, create another image BMP2, and let us put it in one more picture box. Let us put it into one more picture box, say picture box 3. We have not changed the name, it's picture box 1. So let's perform. So let's take first sequence. Bitmap. And if you now browse and give sequence 3, it differs from this in both this direction and this direction. When you try to calculate motion vector, you will be getting a motion vector like this. So this is the simplest form of motion vector calculation.